Okay, so I kill this, and what? Could you attach the notebook in the Google form? I'm not sure. So I think if you, yeah, for homework one, so someone is asking, could you attach the notebook in the Google form? I'm not sure if you'll be able to attach the Jupyter notebook. I'm not, maybe if you have a Gmail account, you could attach it, but I think the better thing is if you just copy and paste it in the sheets, then I have everybody's homework and I could easily grade it. This is for homework one. For homework two, is more or less the sheet is there and you just fill in the answers. Okay. In PDF format. Yeah, you could try and then let's see what happens. Yeah. I think homework one you can easily submit. Try again, Colette. Yeah. Yeah, please try again, Colette. Yeah. I think. Sorry, what you're seeing on the screen has no connection with what you are doing. So let me start the Jupyter notebook. Okay, and I start my Jupyter notebook. Okay. I share this screen. And I go to the Jupyter notebook. So I think I go there. So I look for an Anaconda. I'm sorry, I have an old Windows 7. So I look for Anaconda and I start the Jupyter notebook. Okay, so I go to new and I do Python 3. Okay, so I know it's I can execute something, type something and execute because it's green here. So I'm going to just start my let's do my age is input. So we're going to read an input. Put a space after. Okay. So this I can run this and it's going to ask me for my age. So I run it. It's ask me for my age. Let me tell him I'll put my age as 18. So when I do this, if I print,
sorry, I'm not seeing your screen.
Oh. Okay, can you see my screen now?
Yes.
Okay, good. Let me change this PDF form. So I put here what is my age equals input. What is your age? So this input, what is your age? You take as input whatever you type to it, but it takes it as a string. Okay, so whatever you type to it, even if you don't have a question here, you just still read whatever you give to it. We put a question because it helps us. Okay. So you ask what is your age? So I put 18. So this 18 that it has put, it is not a number. It is actually a string. Okay. So if I print my age *4, let's see what happens. Shift enter. Okay. So it did not print 72 because in that case 72 will be 18, the integer times 4, but it printed 18 4 times. Okay, so it's 18181818 because my age is a string when it takes it in. So you need to convert it from if you want to use it as an integer, you need to convert it to an integer. So I can say my age. So my age at this point is a string. Okay. The other thing also is so I can print. So it's 18, and it appears to be an integer, but it's actually a string. The interesting thing about it is also you can access strings are stored as list. So I can access my age, element 0 of it. Okay, that is 1. And I can access elements 1 of this, and that is it. Okay. So if I put my name, it actually stores this as kind of like a list. So I can access my name, the element 0 of it. So that would be O. And I can access element 1 of it. And that will be M. And you can go on like that. Okay. Okay. So let's do something different, kind of different, that let's do something kind of different that will help us to use a formatting statement. Okay. So we are going to do print now. So we're going to do print now. So you already know how the print function works. So I can just type anything you put in the print function is going to type it out for you. This is what we know so what we know so far is whatever you put in the print is going to print it out for you. And we separate all the things by commas. I can print my name, I put a comma, and I put name. So this these two things is going to these two things is going to print them as strings because they're string. My name is a string. My second name is also a string. So I do shift enter to print my name. Actually, I should have put a space now. My name is, but you see after the is, it automatically puts a space for you. And then my second name is, after that also there's a space, although you don't see it. So let me write this. I can do this. So instead of writing this way, I can put my name here. So I can, since I already put my name in there as my name. Sorry, there are too many my name. I can put this variable. And then it's just going to write my name is the string I gave to it, a space, and then it's going to print the value of the variable my name. So I can do shift enter, and it says my name is Honorable. And then my second name is, because it tries to write the second thing. Okay. Oh, can I enlarge the window? Yeah, I thought I did. Okay. No, but this is kind of true. Let me see. Is this okay now for everybody? So this is the regular way to print that we all know. And so you can just print different things and you can separate them by commas. But you can do some other thing. There's another way to print, which I'm going to tell you. So let's put my age. Let's say this person is 18. Okay. I'll change his name to Alex. Okay. So Alex is 18 years old. So I have those two. I can go back so you see this. My age is 18. My name is Alex. Okay. So what I want to do is I'm going to use a special format statement. So I'll explain this special format statement to you. So you write something in quotes, okay. Then you separate with a comma. Sorry, you separate with a percentage, and then you write all the other variables in brackets. So this is the way to do this. This is a new way to format things. Okay? The old way you knew that we did is basically just this. You write everything and separate them by commas. Okay? So you can still do this, but then I'll just show you another way that you can do it, and it's kind of more elegant and everything. Okay. So the way is you put whatever string you want here. Okay, and then you put a percent, and then you put the variables here. So this is how you do it. So let me give a particular example. So this, I'm going to make a comment. So the way you do it is, let's print. So I'll print my name. So everything I'm going to put in quotes is put %s. %s means a string, and my age is, no, and I am %d years old. So this %s and %d are placeholders. %s is a placeholder for a string, so S for string. %d is a placeholder for integer. I don't know why it's t, not I. Okay, and then %f is placeholder for a float. So this is another way to do this, and then I'll put a % here, and then the variables. The first variable is my name. The second variable is my age. So it's going to do my name is, and then this is the placeholder for a string. So it's going to take my name here, which is a string, and replace this %s. And then I am %d years old. It's going to take, so this %d is a placeholder for integer, and it's going to replace it by my age. So I do shift enter. So you see it says my name is Alex and I'm 18 years old. So this is one way to do it, but this is not the only way. You could have said my name is, another way to do it could be print my is, and then you put a comma, and then my name. Then you put a comma, and so actually you have to put a space here. And you put a comma. So you could do this also. You get the same result. My name is Alex, and I am. Okay, I think maybe I didn't have to put a space here. Yeah, my name is Alex, and I'm 18 years old. It's similar to what we had before, but in this case, you can put all the variables at the end, but you have to remember to put placeholders in here. So this is one way to do it. Okay. So at this point, we are talking about print statements. So we looked at how to take input. So now we are talking about print statement, and then after print statement, we start talking about making decisions. So if loops, while loops, and other loops. Oh yeah, what is the role of %s and %d? So %s is a placeholder for strings. %d is a placeholder for integers. Okay. See. Can I see the upper part of the code for 1 second? Can you analyze the middle? Okay. So to so if I go up, I think you can see the upper. Yeah, so you can see the upper part of the code. My age is 18. My name is Alex. So in this case, 18 here is not a string, it's an integer. Okay. If I put it in quotes, then it becomes a string. And so in that case, this percent %d refers to, is a placeholder for an integer. There are other fanciful things you can do, and then %f is a placeholder for a float. Okay. So there are different things you can do this way. Well, I met the beginning. Okay, let me go to the beginning. So this is the beginning. You will use this, which we did yesterday. What is your age? And you can put 18. So when you do this, anything that you use input for, it takes it as a string. So even if you type 18, 18 is a string. So when I print my age star 4, it just wrote this string 4 times. Okay. So it didn't write 72, it wrote this string 4 times, because when it takes in my age here, it takes it in as a string. Okay. If you want to convert it to an integer, then you have to do a typecasting and typecast it from string to integer. Then I quickly show that when it takes in my age is, sorry, when it takes in a string, the string is actually stored as a kind of like a list. So you can access the 0th element, and then you can access the first element in this case. Or in the case where I put my name is Omorolu. Then this first character is the 0th element of the list called my name. And M is this first character, O is the next character, L is the next character. So you could see that all down. If I remember, I'll do an example with this. Okay. Okay, so I think, okay, so the thing, so we just finished print, we'll quickly finish print statement. What if you want to print, okay, there's a special character. Okay, so let me do it right. So %s is for string. %d is for integer. And %f is for float. Okay, so these are placeholders for these things. Okay. I didn't execute that, but it's fine. So I can execute it. You just comment. The neat thing about print statements. So this is just telling you a little bit more. So the neat thing about print statements is you can use special characters. So I can write something like this. I can put a special character here, T. Okay, so I put this word. Because I put, so special characters, you put slash, this backward slash, and this T is no longer T, is a special character. So backslash T is a special character, and what it does is it gives a tab. Okay, so if you execute this, it will be this, then there's a tab, and there's world. So you see there's a tab here, and then there's world. So this T tab, and then this one, then new line. If I didn't put backslash there, it's just going to print T. But with the backslash, it's going to print. Okay, the format I just did. Oh yeah, so let me show the format I just did. So this is the format I just did. So you print before, so it's print string, then you put a percentage and you put all the variables. So in this case, I put my name is something and I am something years old. So %s is a placeholder for string because I'm going to put a string there, my name. And then %d is a placeholder for an integer because I'm going to put an integer there. Okay.
What is the other percentage before my name and my age? The percentage outside the quotation. What is the benefit of it?
Yeah. So is this percentage is to separate.
Just a separator.
Yeah, exactly. It's to separate. Yeah, it's a separator. But it's a, you can't just use any separator. You have to use this separator, %. So you have to do something like this. In quotes the string with all the placeholders, and then you put a %, and then you put all the variables. So this is the format to use for this. Yeah.
Sorry?
Thank you.
For the separation, can we use \t instead of the percentage?
No. For this format, you have to use percentage. The string and the placeholder, you put it here. Then the only thing you can do after that, so this is rigid. You just have to put %, and after that, the set of variables. Okay.
Thank you.
I haven't noticed. Thank you. It's clear now.
So within, just like you can put %s within the string like this, you can also put some special characters. You can put a tab. To get a tab, you put \t to give you a tab. To get a new line, you put \n to give you a new line. Someone will say, what if I want to print a slash? You can do this, and then this is not special characters. Okay, so this works. Then the other thing, you may need to escape characters. What do I mean by that? What if you want to print something like let's say you want to print something like you want to print something like this. I'm trying to think of a place where I have a slash normally. Okay. Okay, let's start with something that is mundane. Let's say I want to print a statement that reads, this isn't fair. How would I do it? Okay. You see, there's a problem. If you try to do print, this isn't fair. Oh, actually, this will work. Okay, let's try this. Let's imagine you decided to use single quotes. This isn't fair. This is not going to work because the program will think that this is the first string. Okay. And then you have this, ouch. This is the first string, and then you have something else, and it doesn't know what to do with it. So if you try to execute this, you're going to get an error. You see, it doesn't work. In this case, the easiest thing to do is to use different quotes. So you can put a double quote here. And okay, let's do this. So I'll say that this will not work. The single quotes. And not closed. So what will work? In this case, this will work. Print. This isn't. So in this case, this will work because then you can know that the double quotes complement one another, and then you put something there in between. Okay. But let's say you want to write something like, in the US, you write 5 feet 9 inches. Okay. This is how we write we write 5 feet 9 inches in the US. Okay. feet 9 inches. So let's say you want to write that I am 5 feet 9 inches tall. How are you going to write it? If you do this, then there's a problem. I am 5 feet 9 inches. Sorry. So this is a problem. This one, there's no problem, but this one is a problem. So one thing you can do is you can escape the character. Okay. So you put a slash like that, then it will not treat it like your regular character, but you treat it as as a special character. So I can hit return and it prints it. I am 5 foot 9 inches tall because I escaped it. Okay. So this is useful. You print things. Yeah. Yes, you can. In this case, yeah. Okay. Yeah. So you can try to quote the apostrophes, but in this case also you can escape it. Also, if you wanted to print, okay, let's do this. I'll show you this. Remember I told you like \n is a new line. So if I do print hello world, to print hello and then a new line and then world. So I hit enter. So you see it print hello and then a new line and then world. Okay. Okay. There are different other things you can do with it. So I think we'll just stop here because there's a way to make sure that the escape character does not work, but we don't need to do that now. Okay. Any questions so far? So because now we'll move on to making these choices and decisions. What replaces the floater format for real variable format? Okay, yeah. So let's do that since you asked. So let's do print. I'm trying to think of something that. Okay, I am %f meters tall. Let's put. Then we put % here. I will put the variable 1.84. So if you do this, you just print 1.84000 blah blah. Okay. So you may decide that okay, no, I want something that is 2 decimal places. So we put 0.2 for 2 decimal places, and then I want everything to be 4 characters long. So I do this. Okay. So it gives me exactly something that is 4 characters long and is 2 decimal places. Okay, 84. I can make it 5 characters long. But if you okay, let's make it something longer and still 2 decimal places. Sorry. You will see that if you just give more space to the left, so that the whole character is still, everything is still. Let's do eight characters in all, and then 2 decimal places. Okay. So it fills everything with space because I asked for 8 characters. Everything apart from everything from here, not from there. Everything from here up to here will be 8 characters long, and then 2 decimal places. So you can do something like this. Actually, this Jupyter is already being saved as so. Okay, so of course, so someone asked how can I save? You can just save it here, but I usually do Control S and it's already been saved. And then of course you can click Save As and save it to something else. But actually, before you do that, you have to know the path in which you were your default path. So when I opened it, my default path was slash, and I need to know what this slash refers to. How did I do that yesterday? I think if I go to all folders, I don't remember. Does anybody remember how to do this? Because I was able to know where I was. I think I cheated to know where I was because I could.
In my own case, it will go to my own.
Probably
Yeah, but
it will be in the
Hello?
folder you opened.
what?
If you launch the where you launch the Jupyter.
Hello, in my own case, it will go to my own.
Yeah, I understand. It goes to your home. Okay, it depends. If you are using Windows,
I'm using Linux.
so if you are using Linux, you can do it from where you launched it. Okay. But let's say you are using Windows, then where does it go to? I'm trying to figure out how I knew where it went to yesterday. I think when I clicked, I'm trying to figure out how I knew yesterday. Yesterday I was able, you can open document from the beginning and create a folder. Maybe, I'm trying to figure out how I knew yesterday that where my folder was, because I needed to send something and I was able to, if I go to save as, does that tell me anything? Enter a book relative to notebook directory, but I don't know what the notebook directory is. And okay, I'm not sure. I was able to do it yesterday, but clueless now. For Windows, yes, then it's straight. Sorry, for Linux, it's straightforward what to do. For Windows, let me quickly try to figure out how did I know this yesterday. Did I go to Anaconda? No. Okay, I'll find out and then let you know. Because yeah, I'll find out then I'll let you know.
Sorry, I think if you go down in the list, you will see it. The file you saved.
Yeah, I'll see the file saved, but then I don't know where it's saving. Yeah, I don't know where it's saving it to. Okay, so the question is, how do I know where it's saving it to? Yes, I can recognize my files. I know, okay, this file is this.
You can always change the paths, even by clicking any of the folder. Then we save it to however we like. It's not compulsory.
So I think,
use the
yeah,
default.
yeah, so I think you can do that too. Like, click the folder and then, like, you get to a folder that you wanted to install it in. So I think you can do that also. Like I can go to documents, okay, and why is it not going to documents? I don't know what, okay, yeah. So it goes to documents, and then in documents I can put the folder here in documents. So I think you can choose the place where you want it to save it in there. Okay. Yeah, I mean Anaconda notebooks, yes, but I want to know what is before the Anaconda notebooks. Yeah. Is it user prayers or is it user something? Okay, or C something. Okay, so this is how you do this formatting, like you would do in Fortran. Okay, there's some other formatting that you can do also, and you can also learn how to do it. So I think next we should go to making decisions. So we'll be looking at if loops, if statements. Actually, we'll be looking at if statements. We'll be looking at for loops. We'll be looking at while loops. Then also try except. I'll explain all this to us as we go. We'll be looking at something called iterables. Iterables. Okay, we'll be looking at how to make iteration and how to iterate some things. Okay. Of course, we also need condition statements. So we'll be looking at all this today. We have quite some time. Okay, so let's first start by condition statements. Okay, we've seen many of this before, so you can. Okay. So they will return whether something is true or false. So there's equal equals, which you use to check whether two things are the same or not. So you don't use equal to check whether they're the same or not. You use equal equals. Okay, so an example is, I say 5, don't leave a space. So I say 5 equals 3. 5 and 3 are not the same, right? So if I hit enter, it tells me it's false because they're not the same. So apart from that, we can use not equal. So I can write that 5 not equal to 3. So I'm telling it will tell me whether 5 is equal to 3 or not. Sorry, I'm putting everything on the straight line, but you don't have to put it on the line. You can put it on another in another cell. You can check whether something is greater than. You can check whether something is less than. You can check whether something is greater than or equal to. You can check whether something
means what, Omo? Sorry.
Not equal to.
Not equal to. Ah, okay. Okay.
Okay, so in that case, let's do it one by one. So if you do x equals y, x equals y. Is equal. Okay, I think you need to be careful with this when you are dealing with things that are not integers. I mean, when you're dealing with floats. So it's 5.00 equal to 5.0001. So you need to be careful with that. Okay, so this is false. Then you can do not equal to. So this exclamation means not equal. And do 5 not equal to 3. And it tells me true. 5 is not equal to 3. I can say 5. Okay, I can say x is 5. And then I can do x not equal to 5. Or let's do x not equal to 3 plus 2. So it says false. Because x is 5 and 3 plus 2 is 5. So they're the same. And then you can use other ones. Less than, greater than. Greater than or equal to. Less than or equal to. So be careful. So the less than or equal to is written this way. So you put the less than before the equal to. Okay. So these are comparison operators.
Is that a full stop or a comma here?
Well, there's a comma.
Less than. Yes.
The comma. Sorry, thank you. So all of this you can try out, and then okay. Then there are logical operators. And so there's or. Sorry, you can start with and. There's or. There's not. Okay. So you use them to combine multiple conditions. So I won't go into details. You all know if both of the conditions are true, then it returns then and will return true. If one condition is true, the other is false, it will return false. And so it's just like your truth table. If both conditions are false, it will return false. So you can do something like 5 greater than 3, which is true. Or let's do and 3 greater than 4. You see, the first statement is true, but the second statement is false. So this will return what? So what is this?
It's false.
Exactly. So it returns false because yes, one is true, the other is false, so it returns false. Well, we can do the same thing with all statements.
So it will read the last one, right?
No. It will check both of them and see if both of them are true, then it's true. If one is true and the other is false, then it's false.
Ah, okay.
Yeah. And then for or, it will check if either of them are true. And means both of them have to be true, and then it will return true. If either of them is false, then it will return false. Or is if either of them is true, then it will return. So 5 is greater than 3 is true, or 3 is greater than 4, which is false. So this will return true anyway, okay? Because it's an or statement. And yeah, it's an or statement. Okay. So the other thing is you can use not. Not just negates. So you can say something like not 5 greater than 2. So 5 is greater than 2. So that's true. So not will make it false. Okay.
False. It's false.
Okay. So now the next thing we'll talk about if statements. I'll give you the general form for the if statements, and then we'll now take an example. Yeah, I'll give you a general form and then we'll now take an example. So the general form is if condition 1 okay, I'll just give you so it's typically that if condition 1 is met, and you put a colon like this, then you tell it something to do. Let's say you do A, okay. So this is typically how you do it. You indent, okay. And then if condition 1 is not met, you use else if, but you don't type else if, you use elif. It means else if. We will see an example just now. So if you do something else,
how many spaces do we leave?
Okay. Well, it depends. So, but you just have to be consistent. We'll do it just now, and then you'll see. You just have to be consistent with the spaces you leave. Okay. And then you can use as many. Actually, here I shouldn't put this. You can use as many else if as you want. Do something else. Finally, the last one, you do else, and then you don't put else if, because if none of the other conditions work, then you want it to do this. Okay, so you end with else. So you have as many elif as you want, and then you end with else. You can also have only if condition without else. Just say if A equals B, then you should do this. You can do that also, and you don't need an else. Okay. Let me see. Oh, if okay. Okay, so Chris is asking a question. Let's quickly do it. So the question has to do with. Let me check this. The question has to do with this. Okay. So this we said this is going to return true, right? It will return true if either of them is true. If 5 is less than 3 or 3 is less than 4, it will say true. So you can think of it as a statement like this. So in this thing, these statements that I've written, is 5 less than 3 or is 3 less than 4? Okay. 5 is not less than 3, but 3 is greater than 4. Sorry, but 3 is less than 4. Okay. So because 3 is less than 4, one of them is true, then it will return true. Or if either of them is true, it will return true. Okay. And both of them have to be true for it to return true. Okay. So if you do this, it will return and tell you that the answer is true. Okay. Just because you have or there. Okay. Okay. So let's take an example with if, and then we'll see what's happening with if. Okay. Yeah. So another way, I think somebody in computer science, I think he's in computer science, is showing us what to do. You can think of or as a plus sign, and if it's true, then it's 1. If it's false, then it's 0. Okay. So these are things from logic, a course in logic, computer logic, or even philosophical logic. Yeah. Okay, so let's write some code. So I'll put user input. So you remember this, we've used it before. I want the user to enter the number 1 or 2. I put a space because I don't want everything to jam together. Okay, so this is going to ask you to enter 1 or 2. Okay, so then if the user input, so you remember this is going to return a string. So if the user input is 1, but I have to write it as 1 a string. I don't just write 1, I write 1 a string because it's going to return a string. So if the user input is 1, I want it to, you see, I just hit enter, and because I put this colon, this thing gives it 4 spaces. I think the standard in Python is 4 spaces. There should be a way somewhere where you can change the number of spaces it puts. I don't know exactly, but there should be a place where you can change the default to 2 spaces. But you see, the moment I hit enter, the Jupyter Notebook is smart to help me. Many ideally are smart this way also. So this is an advantage of using ideally. I typically don't use an ideally, I just use VI. And actually I find it annoying when sometimes the VI is already infected by this knowledge of knowing that I'm using Python. Okay, so many idealists do that, but usually I'll use my space bar to give, I don't use tab, I use my space bar to give like 2 spaces, but this one gives 4 spaces. Okay, So if user input is 1, let's tell it to print hello world. And then a new line. Then how are you? Okay. So to print hello world, a new line, how are you? Okay. So when I hit enter, it tries to start from the same place, but then I know I need to write another statement. So I move back with my backspace. So I'll write elif if user input equals. Then you should do something else. So I'll this. So let me see. I may have to escape this. I don't remember. Wait, what? And then I'll print also. Just works. So I think I may have to escape it. I'm not 100% sure. Okay. And now I want to finish with else, because some of us can type something instead of 1 and 2. You can type something else. Okay. So I will tell it to print. So I just type else and then print your number. Okay. So it's going to prompt and it's going to ask me to enter 1 or 2. If I enter 1, it's going to do this. If I enter 2, it's going to do this. If I enter something else, it's going to tell me my number is invalid. So this is simple way to do this. I hit shift return, enter 1 or 2. I enter 1, I hit enter. It says, hello world, how are you? I can run it again. Shift enter. Write 2, I hit enter. Python is cool. Okay, so now I know I don't need to escape this. So I remove the escape and I remove the escape. I shift enter. I put 2. I hit enter. In the terminal, Python is cool. It just works. So let's be like a rebellious kid and do shift enter. I'm going to say enter 1 or 2. I'm going to say 13. Okay. So it says your number is invalid. So it works. Okay. You can actually let's talk about this special one called inline if. So inline if works like this. I'll put a comment. So
Can I ask you a question quickly?
Yeah.
What's the role of the backspace in Python is cool?
What's the role?
The backslash.
I thought I need this.
It's not a backsplash. It's from me, so
I remove it. I thought I needed to escape this, but I don't have to. I think you are doing my shell, you may have to escape it.
yeah.
Yeah.
It's noisy. I can't hear you.
Oh, I don't have to escape it. I thought I needed to escape this exclamation point. I thought it will see it as a special character that I need to escape it. So that's why I did this. But when I ran it, I saw that I did not have to escape it. Okay. You escape a character if okay, I did it because I wasn't sure if you recognize it or I have to escape. Make it a special character for it. When I recognize it, and I didn't have to make it a special character, so I removed it. Okay. So inline if, yeah, you do task A, yeah, if condition is met, yeah. Yeah.
You don't put the semicolon, doesn't work. Why?
Don't put what?
If you don't put the
You don't put what? Oh, this semicolon. You need to put the semicolon. Yeah. You need to put the semicolon in the if, the elif, and the else. Okay. If you use inline if, which I'm giving you an example like this. So do task A if condition is met. Else do task B. So this is the inline yeah, it is a colon. Yeah. Thanks. So I'm going to explain this this thing. So I'll say num1 equals, what's num1 equals? It could be 12 if user input equals 1, else is 13. And do it this way. So num1 is 12 if user input is 1, else is 13. And actually now there's a bad thing. Actually, if I run this, it's not going to run now. It's not going to give me any value for num1 because the last value for, so let's try it. Print num1. I print 13. Oh yeah, sorry. It works. So it will print 12 if the user input 1. Otherwise, it will print 13. So remember, the user input that we got was 13. Sorry, this is bad. So let's print here 21. Okay. Let's do this. So if the user input is 1, it prints 12. Otherwise, it's going to print 21. Okay, so I hit enter. So remember, the last user input that we had was 13. And that code said it was an invalid number. So now num1 is this. So I do shift enter. And then I tell it to print it. Print num1. So you're going to print 21. Because user input was not 1. User input was some other number 13. If user input was 1, the string 1, it will have printed 12. If not, now it's printing 21. The interesting thing actually is that you don't need to put this bracket that I put before and after. The bracket helps you to read it, but you don't actually need to put it. You could have put something like this. So you're saying what's num1? It will be 12 if user input is 1, else it will be 21. Okay, so I've written it this way, which seems cryptic, but writing it this way is better. So it could be 12 or 21. So this is an inline if. Okay. The other thing that happens is sometimes you may have only one statement that you want it to try. And in that case, you could just try it. You could just say if num1 equals 12, then you say x equals 23.5. So this is fine. Okay, and you don't have to put if else. So I know I told you do if elif, if elif, if elif, elif, elif. Oh yeah, okay. So this is the interesting thing about the Jupyter. This is a session of Python, and all the variables that you are putting, they are there in memory. So if I type something now, all the variables are there. You can change the variables as you go along, but it remembers all the old variables. You can interrupt the kernel. and remove all the variables that you had before. So if you go to kernel, you can restart actually the kernel. You can also restart and clear all the output. Okay. It will clear just the output. It won't clear the input that you put there. Okay. So you can do that. So if I do restart kernel, then okay, let's try. If I do restart kernel, you see it tells me all the variables will be lost. I do continue running. So now num1 does not have a value, does not have a sorry, user input does not have any value. It's probably nil. Okay, so actually this code in this, so if I let me open a new cell. Okay. So if I say print num1, I don't know what happened. I thought I cleared the kernel. Sorry. I think I will restart the kernel. All variables will be lost. I say continue running.
We should be restart.
You should hit restart, not continue. أحكي مع
Yeah.
الأستاذ.
Right.
Yes.
Yeah, I did restart.
Click. Then the red.
Oh, continue running. Ah, my goodness.
Restart.
Okay. This is my sign that I'm tired. This is totally like ridiculous. Thanks, Hala, and thanks for helping me. Because I'm like, what in the world? I cleared the kernel and it's still there. So if you do print num1, thank you. It gives you an error that the name num1 is not defined. You may say, oh, I defined it before. Yes, you defined it. But when you cleared the kernel and you told it to restart, oh, okay. And you told it to restart, then it cleans everything. Oh, yes. Ezekiel, thank you very much. There's a mistake in this line. This line should be if num1 equals 12. I'm doing a test. Actually, this is a buggy and bad bug because it's going to, if you just put num1 equals 12 like this, if num1 is 12, it's going to execute this num1. The execution will succeed and return true, I think. Either, I don't remember. It will return something, and based on that, it will decide whether to set x to be 23.5 or not. And it has nothing to do whether num1 is 12 or not. Okay, so this is a bad mistake. So I should put this. So I'm checking if num1 is 12 or not. Okay, I'm not assigning. And if it's 12, I want x to be 23.5. Here I'm assigning. Once you assign and it's successful, it will return. Let's see what it returns. Okay. Before then, so you see, if I print num1, because it's not defined anywhere, it tells me num1 is an error. Let me try this. Print x equals 2. So what I actually wanted it to do was to allocate x to 2 and to print it. I'm not sure if this works. Okay, I have to think about this. Okay. So in this case, I cleared the kernel. So let's go back. I cleared the kernel. Yeah, exactly. So this is not what I want. I actually want to test whether num1 is 12. Okay. So thank you, Ezekiel. So I cleared the kernel, and then now there's no num1 and there's no user input and anything like that. Okay. So all the variables you used before are kept in the memory. So you can reassign it and everything, but they're all kept in the memory. Okay. So I think we can move on now to for loops. Okay. Does anybody have questions? Okay, so the usual thing we tell people is that instead of saying user, user 1 is 10, user 2 is this is this, user 13 is this, user 21 is this, we can use a for loop to assign everything to everybody. Okay. Yeah, you can use a for loop this way. So let's see how to use a for loop for things that are iterable, those are list and dictionaries. So we see how to use for loops.
Hello?
Yes.
Sorry, I think it's the last statement you made before I come to form. When you say that something is kept in the memory, I don't know, I didn't understand what you mean by that.
Okay, so all the variables we are using now, they're in the memory each time you use it. Okay. Okay. Each time you use the variables, they're in the memory. Okay. And so once you use it, even if you use it somewhere for that kernel, actually, when you start your Jupyter, everything, it starts with a fresh memory. And as you put the variables, everything stays in the memory. So even if you
is it in the kernel?
Yes, if you start with a new kernel, everything stays in the memory. Okay, so what that means is that. So what that means is that if somewhere here I put, okay, my age is 18, then, and my name is Alex, as you go down and do different things, it still remembers that my age is 18.
Okay. Unless you overwrite it.
Yes, you can overwrite it and put my age is 23. Okay, so it's still there. But that variable is still there. Okay. If you create a variable before, okay, so for instance, and we never used X before in this work. I mean, today, maybe we use X. Maybe we use X. Let's talk about X2. Okay, so X2, we never use X2. So if I say print X2, it's going to give me an error. Because X2 is not defined. So you read the error, X2 is not defined. You need to define it before. So I can now define X2 is 23.5, and then I can print it, and then there's no error.
Okay.
The interesting thing is that if X2 plus equals X2 plus 5, it remembers this X2 and is going to use it again. So even if you work, yeah, go ahead.
But when you open a new kernel, it can't reference this again.
Yes, it doesn't reference this. The other thing also, you can actually restart the kernel. And if you restart the kernel, then all the memory you had before will be lost and it will start afresh. And you don't have to in your Jupyter notebook. Okay? But it's fine.
Okay. Thank you.
Yeah, sure. So let's look at for loops. But we'll first of all look at for loops for list and iterable objects. Okay. So we look at it for loops for. So we'll call it looping. These are objects that you can iterate through. Okay. And the way you do it is for you can use any symbol. So I can use A in iterable. I put a colon and I say print A. So this is how you use it. So let's take an example. Okay, so let's take an example. Let's take an example of, I say X correlation function. Okay, so we are going to put your favorite X correlation function, not PVE. Someone says he prefers Blip. Someone says he prefers PW or PZ. The modern person says he prefers HSC06. Okay, so these are examples of the exchange correlation functionals. So I've created a list. I can, let's say I want to print each item on the list. I just want to print it one by one. So all I have to do is I can say for A in XC, if you do this, you should print A. Hit enter, and then it's going to print each of them one by one. So just print each of them one by one. Okay. It iterates through the loop, through the list. So the first time that the code runs through the loop, the first time A is PB. Okay. The next time it goes through the loop, A is Blip. The next time is PW. The next time is PZ. The next time is HSC06. Okay. Okay, then it prints it, and then you have this. Yeah, so this is a good question. Someone is asking, where is letter A in the code? This is interesting. There's no letter A in the code. You decide, you put any variable you want here. So it's going to assign the first thing to this variable, and then the second thing to this variable, the third thing to this variable. And then at the end, it's going to print this. The interesting thing, it works just like many languages. Let's try. So if I print A now, see, A is HSC06 because that was the last value I put in A. So when it goes through this loop, the first time it's going to make A. So A is just a variable. So the first time it's going to make A PBE. The second time A will be Blip. The second time is PW, and on like that. And then the last time, in this case, is HSC06. Okay. So after it goes through the loop, if I tell it to print A, it will print the last value that it puts in A. So A in this point is just a variable. Okay. So we say, what if I want you to tell me that PBE is index 0, Blip is index 1, PW is index 2, and on like that? What do I do? Okay. So you have to use something called enumerate. Okay. So when you enumerate, you need an index and you need something else. So if you do enumerate, enumerate will return. Let me try this. I don't know if it will. Sorry, let's do. Thanks. Enumerate X. Let's do this. Let's try. Okay, it's an object. So what I can do is I can let it enumerate, and then I can print each element of the enumeration. So I'll show you how it works now. Yeah, okay. So I'll show you how this works with enumerate. So in this case, I want you to tell me that index 0 is this, index 1 is this. So all you have to do is for index A. So A in enumerate. So enumerate is going to return returns an object. The object will have two things. One will be the index in XC, the other will be the object. So it will be index, object, index, object. So I'll say print index and A. So now I hit shift return. So you see it prints 0 PB. This does not have to be index, it could be IP. So it's just two things, IP. Hit enter. Okay. So enumerate will change XC into something that has the index and the item. The index, the item, the index and item. So IP. So this pair, which I call IP and A, will be one element of XC. Oh, sorry, of enumerate XC. So enumerate XC is going to, if you like, form a dictionary of the index and the element, and the index and the element. So now I iterate through it. So let's go one step back and do this, okay? So you see, I declare this XC. I don't have to say, yes, this is not the only way I can do it. If I print D, you know, no, you won't have it's not okay. You can use any symbol for this. So you can put JJJ, print JJJ. So it's just a variable that you introduce. Okay, so you can use any variable. So let's go and see this. So this is the list, and I define a variable JJJ. This variable will take different values. The first time JJJ will be PB, so it will print PB. The next time JJJ will be bleak. The next time JJJ. So you just define a variable. You can call it any name, any acceptable name. Okay. So then I just print, and then it's going to print, go through the loop and print each of them. Okay. So remember this syntax. That's why I'm putting it up. So you put this for J, you have the list, and then for J in JJJ in this, you print it. So it's going to print it one by one. So this is very important syntax, and I want you to remember it. You don't have to actually. You don't have to know this list. Okay. What you know is, yeah, I could have created the list and you didn't know about it. Okay. But the main, for instance, you can read in a list, and the main thing is that if you iterate through it. So you don't have to, in this case, I have to put a list before it iterates through. But even if you don't see the list, you can just do this. Of course, there's another way to do the same thing, but this is the simplest way to do it. Well, another way to do the same thing is, should we do that now? Okay, we'll see. If I remember, I'll show you another way to do the same thing. It's a little bit more cumbersome. Okay. Yeah, so we'll do this. It's a little bit more cumbersome, but then it follows the same approach. Someone is asking, how can we print matrices and vectors? Okay, so I'll try to think the best way to do that, because actually the best way to work with matrices and vectors is not to use the native Python list, is to use arrays from NumPy, numerical Python. Okay. And there's a good reason why it's good to use NumPy. So yeah, okay, yeah, so we could use numbers for an example. Yeah. So there's a good reason why it's better to use NumPy, and then we'll see that reason later on. Okay. So this is if you want to know which index, so you can do this for IP, comma A, and then enumerate, then you print the index, and you print the variable. So this one I can call it BB if you want. And you click this, and it's going to do that. You can do the same thing for dictionaries. So for dictionaries, when you print it, it's going to print the key for you. So let's do this. So let's have a dictionary that has, let's form a dictionary, we'll call it compounds. We have TiO2, 3.2. Then we have, let's say sodium. The sodium is metallic, so 0.0, the band gap. And then we have CuCl2. Let's assume the band gap is Sorry, ZNO2. No, that's too almost. Let's do silicon. And gap is 1.1. Okay, so I can do this. So this is a dictionary. So I can look through the dictionary. If you look through it, so I say for I in compounds, I'll print I. So in this case, it's going to print the key for you. So it's going to print the key. Okay. We print TiO2 NaSi. What if I want the key and the element it refers to? Okay, so you can do something similar. It is already printing the key for you. You can print I, compounds, I. You can do this. So in this case, it's going to print the I, which is the key, and it's going to print what's the key supposed to.
Come on.
Yes.
Why are we not using the? Why are we using the curly bracket? What is the difference?
The curly brackets. Yeah. Oh, because I'm making a dictionary.
Ah, okay.
Yeah. So it's a dictionary. So we have this, the key, the element, the key, the element, the key, the element. So this is a yeah. Thanks, judges. Yeah. Someone said something. The result has in. Yes. Can I say the for loop? My Jupyter has no init variable. Ah, no, it does. It has an init variable. By default, the init variable is 0. Okay. So, so at this point, okay. So I think we can. Okay. So let's go back to something I mentioned. So we have message. Let's form a long word introduction. No, let's form a long word. We call it water splitting. So, like I told you, so this is a string, but it is stored almost like a list. So you can say something like for I in message. You can say to print I. So it's going to print. So this is actually message, like say message 0 is W, the string W. Message 1 is a string A, and so on. So it's like doing that. So if I say for I in message, then message is like a list, and if I print it, it's going to print W, and the next line A, the next line. So when it prints, there's a new line that it prints exactly. So I do this. So you see, is water WATER splitting. Okay, so it prints this. So let's think. Okay, so the other, so now the final thing we'll do with for loops. We'll have to do while loops also. Is okay. Let's see another way to print exactly to do this. So remember, we have this list of exchange correlation functional. Where is it? So I'll find it just now. Yeah, we have this list of exchange correlation functional. I won't copy it because it's still there. And let's say I only want to print a part of the list. What can I do? So I can say num is length of xc. So it gives me the length. Okay. And then I can say for I in range xc. I can print I. print I, and I can print XC I. So this tells me the length. What this range does is it creates a list that goes from 0, a list that has num elements, because that's the length of XC. Sorry, for range, not this. I should put range num. Sorry. Okay, so num, I find the length, and then I do for I in range num of this. So what range does is it creates a list. So let me put a comment here. So range 5 will generate list 0, 1, 2, 3, 4. Do range 3, 10, it will generate the list. The list will start from 3 to 4, 5, 6, 7, 8, 9. Sorry, I made a mistake. Yeah, 9. Okay. So it will go from 3 up to, but not including 10. This one will go from 0 up to, but not including 5. Okay. Then also I can do, if I do this, range 4, 10, 2, so we'll generate this list, which will be 4. Then it will go to the instead of 2, 6, instead of 2, 8, up to, but not including 10. So when I say for I in range, no, so in this case, there are 5 of them. The list. So when I say for I in range this, it's going to have a list that goes from 0 to 4, and then it will print 0, and then 1 and 2 and 3 and 4, and then it will print what is in XC. So I can execute it. So it does the same thing like before. But the good thing about this is that I can use this to print only a part of the list. So you can watch this. Suppose I want to print from elements from just 2 to none. So I do this. So it's not going to print all the list. It's going to print from index 2 to up to, but not including index 5. Okay, so it's going to print 2, 3, 4. Sorry. I think I did the right thing. For I in range 2. Sorry, hold on, let me see. Did I declare none? I did.
It's a comma instead of a column. Range 2, comma, num.
Sorry. Thank you. Sorry. Yeah. Oh, this is a clear sign that I'm tired. Yeah, so it's a comma like here, 3, 10. Okay. So for I in range 2, none, thank you. So I do this and it prints 2, 3, and 4. So this is okay. The simplest thing is to say for I in range 3, 10, and then you should print. Yeah, print I. So this will just print 3 up to, but not including 10. So I think we still have time to look at while loops. And then after while loops, we look at break and continue. We should look at try and except also. Okay, let's try. Okay.
Can you
So
please
what?
scroll up so that we can see what you're writing?
Oh, okay. Yes. Let me see. Can you see what I'm writing?
Yes, it's
Okay.
good. Thanks.
Okay, thanks. So you can do while loops also. So while loops basically are like while the condition is true. If you do A. So this is exactly how you use a while loop. This condition, you can put it in brackets, you may not put it in brackets, it's fine. So let's take an example. Okay. I'm going to, you can write it while, you have to be careful with while loops because you can write while loops that run forever. Okay. Oh, okay. You can do while loops that run forever. Okay. So this goes from 3 to 10 and then print I. You have to be careful to make sure that you make your counter change. You have to do it so that the condition is, make sure the condition will be violated something. Otherwise, it will just run forever. If the condition is never violated. Okay, so be kind of careful with it. So let's do this and say counter is 5. So while counter is greater than 0, it will do this. Okay. So it will print equals. I run this is going to run forever because counter is 5 and it's greater than 0, so it's going to run forever. Okay. I don't want it to run forever. Okay. So I'm going to say counter minus equals 1. Okay. So this is the same thing as saying counter is counter minus 1. So the first time it goes through, counter is 5. Then when it gets, it's going to decrease counter to 4. 4 is greater than 0, so it's going to run again. The next time counter will be 3. 3 is still greater than 0 to run again. Then it will be 2, then it will be 1. 1 is still greater than 0 to run again. And then when counter is 0, 0 is not greater than 0, then that will not run. Okay. So let's run it. Okay. So it did exactly 5, 4, 3, 2, 1, and that's it. Okay. So you should be careful that you put a condition there. I mean, you put something there that will make the condition false. Otherwise, it will just run forever. Okay. Now we look at break statements. So for some time when you have a loop, you don't want you don't want the loop to run. Let me put this one. You don't want the loop to run to the end. Once a particular condition is satisfied, you want it to leave the loop and go to the next part of your program. So you do that for efficiency. For instance, if you are looking through some files and you want calcium carbonate or barium titanate, for instance. Once you get the barium titanate, you want it to just stop there and give you the information you need. So you don't need it to go through all the list. So imagine a case where you have a list of compounds and they are band gap. And then you write a code that the user can input a compound and it should tell you the band gap. That code does not need to go through the whole list. So let's say I ask it BATRO3. You should just go through. Once you find BATRO3, you should print the band gap and stop. It doesn't have to go through the list after it has found BATRO3 and now telling me that, oh, this is the band gap for BATRO3. Once he finds it, is enough, it stops. So things like that, you need to use a break statement to get out of the loop. So it's similar to what you do in Fortran and I think C. So I'll give an example. So this we already know for I in range 5. So I'll say J plus J plus 2. We do J plus equals 2. Then I'm going to print I, and I'm going to print J. And then I'm going to say if J is 6, I want it to break. So you can put the break here or you can put it the next line. So it's going to start from 0, and once J is 6, it's going to break. Okay. So it did exactly that. So it printed this one, it printed this. Once J is 6, it broke, it did not have to continue. Okay. Let me go also. Yeah, so here print counter equals the value of counter. The first time the counter is 5, then counter got reduced. Okay, to 4. 4 is still greater than 0, so it runs through and prints 4. And then after, later on, counter is 1 finally. And then 1 is greater than 0, so it prints it. Then it reduces counter by 1. Okay, it becomes 0. 0 is not greater than 0, so it doesn't go through the loop. Okay, so for continue, you just, sorry, for break, you force it when a particular condition is met, you force it to break. Okay. So this is exactly what you do. You can just do this. Some other times you may want it to skip a particular case. For instance, I may say when J is 6, in this case, I don't want it to print it. Actually, no, this will not work. Okay, let's do this. If J is 6, it breaks. Okay. So I'll follow this with a line. It says print I times J. Okay. So in sorry. So I'm trying to think of how I can put a continuous statement here. So if you put continue, then yeah. So let's take this code. The next one I'll write, we are going to put a continue there. So I do this. Okay. So the first time it wrote 0, 2. The next, and then it wrote 0, 2, and 2 times 0. And then 1, 4, and then 1, 4, 4 times 1. Then 2, 6. And then it will print. Oh, yeah, it's did 2, 6. But you see, I told it to break. Okay. So it will quit at this point, and it doesn't print the next line. Okay. So break means it should stop executing the loop. So it breaks, it doesn't print this next line. So I'm going to show you another one, which is continue. Continue just means that that particular one it should skip. It doesn't mean that it should break out of the loop, but it just means that for that particular one, it should not continue the loop. Sorry, you should not continue the rest of the loop, but go back with the new value.
Can I ask you a question?
Yeah. Yes.
You have a second instruction, like a print after the if statement. Why after the if statement, you have another instruction, a print instruction?
Yes.
Isn't it supposed to be shifted by 4 space, blank space after the if?
No, okay. Okay, so, okay, yeah, so this is a good point to discuss, and then probably at this point we'll close for today. This shifting tells you that this whole block belongs to statement. That's what the shifting does. it tells you that the whole block belongs to this statement. Actually, in this case, I could write it this way. So if j is equal to 6, break. So this break belongs to this statement. Well, this print does not belong to this statement. So what I'm doing is it prints I and j, but if j is 6, it breaks and stops. So, no, sorry. What I'm doing is it prints I and j, and then it prints this. So this that I've written is not part of this if statement. If you make it a part of the if statement, okay, it depends on what you want. But in this case, I don't want it to be part of the if statement. So I don't put it in the same, I don't indent it. If you indent it, then it will be part of the if statement. So I don't want it to be if statement. I just want, if j is 6, it breaks. And then it won't print this. These are constructed because I want to show you how to use continue. Continue you use in a similar way, but what continue does is it doesn't break. It just means that when j is 6, it will not print this line, but it will continue and go back to the next iteration. Yeah. So continue means go to the next iteration. Continue means don't continue in the loop, go to the next iteration. Okay, so that's what continue means. So you see in this case, it's going to print ij, and then ij for all the other numbers, but for 6, it's not going to print it. So you will never see it print 1, 6, 4, 6, and 4 times 6. So it won't print this. So let's run it and see. So you see it prints 2, 6. And then it prints 3, 8. Ordinarily here, it should have printed after this 2, 6, 12. What I told you to continue means don't continue executing the loop, just go to the next iteration. Okay. So remember the code. So I think I'll stop it. So let's see what the code does. Okay. For I in range. Okay. For I in range 5, it does j is j plus 2. So j was 0. If you add 2 to it, and then it prints I and j. Okay. So I will be 0, 1, 2, 3, 4. And then j will be 0, will be 2, 2, 4, 6, 8. Yeah. So that will be j. Okay. So it prints I and j. And then if j is equal to 6, it's not going to print this. It's going to go to the next iteration. So for all the other elements, it's going to print them. Let me go down. Okay. So for all the other elements, it prints 0, 2. Okay. And then it prints 0, 2 and 0 times 2. Then it prints 1, 4. And then it prints 1, 4 and 1 times 4. Then it prints 2, 6. But you see, it doesn't print 2, 6 and 2 times 6. Because I told you to continue, meaning don't bother to execute what is left in the loop. Just continue to the next loop, to the next iteration. Okay. So the next iteration is 3, 8. Okay. And it prints 3 times 3, 8 and 3 times 8. The next one is 4, 10, and it prints 4, 10 and 4 times 10, which is 40. So this is what continue does. Okay. So let me take 5 minutes and do try except. So sometimes some things cannot be done. You want it to try it, and if there's an error, you don't want it to exit and say, oh, there's an error. So for instance, if I do answer equals 12 over 0. I'm dividing by 0, so this will give you an error. Okay. So it gives you an error, division by 0. But what you can do is you can try it, and then if it gives an error, I don't want it to give an error, but I want it to do the exception. So I'll show you how to do that. So it's try. So please give me like 4 minutes and then we'll be done. So you try to do something. If it fails, then it does accept. Do something else. So this it does. It does this something else. If the try fails, it does this something else. So let's see how we'll do that in this case. Okay, so I'll try answer equals 12 over 0, and then I'll try to print the answer. If it fails, you see when I hit enter, it goes to where it thinks I should write, but I use my backspace to do this. So except, I'll say print. There was an error. So now I can run this. This will not give an error. Okay. If you just print this, because in the first case you see that it gave an error, now it will not give an error, so I can run it. Okay, so it tells me there was an error in the division. The reason is it tries this. When this fails, then it goes to the except. Okay. There are different things you can do with except. We won't do that now. I can send you a link to be able to do different things with except. But this is the basic thing to do. You try something, and if it doesn't work, you have an except. For instance, if you have two variables you are dividing by one another, when the denominator is 0, it's going to give an error. But if it gives an error, you want it to try something else, to do something else. So you can use this exactly for that. Okay, so you try, and if there's an error, it gives something else. Okay, I'll try to remember to send you something about a list of errors. And then hopefully we can start functions and modules tomorrow. Okay. Okay, any questions? So I'll send this to you and other things to you, and then we can meet again tomorrow. Thank you.
Thank you, sir.
Bye.
Bye. Yeah.